Our senses tell us a story. They paint a picture of the world around us, a picture that feels complete and absolute. They describe a world of 3 dimensions: length, width, and height. These dimensions form the very fabric of our reality, the stage upon which all events unfold. We experience time as a linear flow, a steady march from past to present to future. This progression is so ingrained in our consciousness that we rarely question its nature. But what if this familiar framework is just that, a framework, a construct of our minds, a simplified model to make sense of the universe? What if the universe extends beyond the grasp of our senses, beyond the limits of space and time as we know them? What if there are dimensions and realms that we cannot perceive directly? This isn't just a philosophical musing, it's a question that physicists are grappling with as they explore the deepest levels of reality. They are delving into the very essence of existence, seeking answers that could redefine our understanding of the cosmos. At the heart of this exploration is a revolutionary idea that the universe might exist beyond space and time, realms that our human minds were not built to directly comprehend. This idea challenges the very core of our perception. Imagine a universe where dimensions are not limited to 3, but extend into realms that are beyond our sensory experience. This is the realm of theoretical physics, where concepts like string theory come into play. This is not merely a detour from the familiar, but a radical reimagining of the cosmos and our place within it. It suggests that our everyday experiences are just a small part of a much grander tapestry. The challenge lies in pushing past our everyday intuitions. We must break free from the constraints of our limited perspective and open our minds to new possibilities. We're so accustomed to experiencing the universe in terms of space and time that it's difficult to imagine anything else. Yet the history of science is filled with moments where the unimaginable became reality. But imagine we must, for the most profound discoveries often lie beyond the boundaries of the known. It is in the uncharted territories that we find the keys to unlocking the mysteries of the universe. Imagine then a realm beyond space and time, a realm where the very laws of physics as we know them break down, a place where the familiar rules of cause and effect no longer apply, where time flows differently or perhaps doesn't exist at all. Such a realm would be beyond our wildest imaginations, yet it could hold the key to understanding the true nature of the universe. Our journey into this uncharted territory begins with a theory that has the potential to reshape our understanding of the cosmos: string theory. This theory proposes that the fundamental building blocks of the universe are not particles but tiny, vibrating strings. String theory, with its elegant yet mind-boggling propositions, offers a glimpse into a reality that transcends our everyday experience. It suggests that the universe is a symphony of vibrations, each string resonating in its own unique way, creating the rich tapestry of existence we observe. In the realm of string theory, the universe is not a collection of particles and waves, but a symphony of vibrating strings. These strings are tiny loops of energy that vibrate at different frequencies. Each vibration corresponds to a different particle, like an electron or a proton. And thus, everything in the universe, from the smallest atom to the largest galaxy, is composed of these strings. But there is a problem inherent in the theory, for string theorists see the need for an additional level of reality beyond space and time. And some, like physicist Brian Greene, believe that a deeper understanding of the universe will require us to dispense with our notions of space and time altogether. Einstein's theory of relativity was the first to suggest that the notions of space and time were not absolute and universal. They are not fixed and rigid, but are instead dependent upon the motion of an observer's frame of reference relative to other frames of reference, hence relativity theory. A clock, for example, will run slower if it is moving past us than if it is stationary relative to us, and the faster it moves past us, the slower it will run. As counterintuitive as this may seem, the effect is real, and if it were not taken into account, then satellite systems like the GPS network would not work properly. Because of the speed of the satellites relative to the surface of the Earth, time moves at a different rate for them, and if this were not corrected for, then within minutes they would be reporting positions on Earth that were inaccurate by several meters. But string theorists go further than this, and ask not whether space and time are absolutes, but whether they have any objective reality at all. We are in familiar territory here. When we say that we are immersed in space-time, ask string theorists, should we view ourselves as embedded in something, or are the concepts of space and time only shorthand for the relationships between fundamental particles or strings? The idea here is that space and time do not exist on their own as independent objective realities into which strings or anything else can then come into being, but that space and time themselves come into being when all the not yet physically real strings begin to vibrate in the same orderly pattern called a coherent state of strings. Before that, the thinking goes, the strings were disordered and incoherent, and neither space nor time existed. What might that disordered precursor to the fabric of space and time have been like? String theorists cannot say, but Green notes that it would be misleading to imagine this early state as a jumbled mass of vibrating strings, waiting to be arranged into an ordered whole, because such a description assumes the existence of space and time, the space in which the strings vibrate, and the progression of time through which their movement can be tracked. However, in this raw, primordial condition, before the strings align into a coherent vibrational pattern, space and time have not yet taken shape. Even our language is inadequate to convey this concept, as there is not even a meaningful sense of before in this context. One might think of the individual strings as shards of space and time, and only when they resonate in a synchronized manner do the familiar dimensions of space and time emerge. String theory cannot comment on what that primordial state prior to the emergence of time and space might have been like. The equations of string theory themselves presuppose the existence of space and time within which strings can move about and vibrate. And since they presuppose space and time, they cannot explain space and time. To extend the theory's reach, theorists would have to show how string theory could create the dimensions of space and time themselves, by starting off in a spaceless and timeless configuration. Green acknowledges that conceptualizing such a structureless, primal state of existence, one in which there is no notion of space or time as we know it, pushes most people's powers of comprehension to their limit. We run up against a clash of paradigms when we try to envision a universe that is, but that somehow does not invoke the concepts of space or time. Such a clash exists, however, only if we cling to a materialist framework. We must look beyond that framework if we are ever to approach an understanding of what reality is, and we go astray when we attempt to define reality in strictly physical terms. The difficulty here is that there is no place for consciousness in string theory or any other physical theory. If the assumption is that all that can be known of reality is physical and that consciousness itself arises from the physical level of reality and is limited to that level as an epiphenomenon, then it becomes difficult to imagine a state of existence that is, but is not physical. This presents a dilemma for string theory and materialist science alike. If consciousness is assumed to be a byproduct of physical processes, then it is difficult to conceive of a state of existence that is real but not physical. Who or what could be aware of it? And yet, both quantum mechanics and string theory point toward the necessity of a non-physical dimension of reality, while findings in quantum physics suggest that consciousness itself exhibits non-local properties. And if consciousness is not bound by space and time, then it stands to reason that it can function outside of space and time. Science has reached the limits of its current framework, revealing its own shortcomings. Its methodologies and underlying assumptions inherently restrict its ability to fully grasp reality. Physicists are now venturing into realms where even their most advanced instruments cannot reach and where the usual scientific rules break down. Focusing solely on particles or even waves misses the deeper reality of consciousness. Until the fundamental role of consciousness is acknowledged, our understanding will remain incomplete. Scientific instruments, while valuable, can only measure phenomena within the physical framework they were designed for. The dominant model of objective science has provided practical advancements, enabling achievements like space travel and technological progress. However, this model, useful as it has been, will inevitably reach a boundary beyond which it cannot proceed. At some point, objective science will encounter aspects of reality that its methods are simply not equipped to explore, dimensions of existence that are systematically overlooked due to its materialist focus. The physical exploration of reality will always hit the brick wall of inner reality, and it is the study of consciousness, not matter, that will be necessary for any exploration of that inner reality. The universe cannot be its own source. Its deepest mysteries are rooted in consciousness rather than matter, and these will remain beyond comprehension if approached solely through the lens of objective experience. To truly understand reality, we must look to the origin of that experience itself. This is where consciousness enters the picture. While the brain is limited to processing sensory data, shaping raw energy into the familiar physical world, the mind operates on a much broader level, engaging with fundamental principles that transcend the physical plane. Unlike the brain, which can be studied and measured with scientific instruments, the mind cannot even be detected through material means. It is fundamental, not an emergent property of matter. A bridge between different levels of reality that holds the key to understanding the nature of reality beyond space and time. While instruments can probe the physical world, the mind alone has access to the deeper principles that underpin reality. The study of consciousness, therefore, is essential for advancing beyond the limits of material science. Join us next time as we probe the mysteries of consciousness, beginning with a look at psychic phenomena such as telepathy and clairvoyance. And don't forget to hit the like and subscribe buttons. Thank you for watching.